Hi, we're going to find the probability under a normal curve using an example here. So you can see the lifetime of a battery is normally distributed with a mean life of 40 hours and a standard deviation of 1.2 hours. So let's say I own a battery factory and I want to figure out, well, I know just from checking my batteries as a random sample of the batteries coming off the assembly line that the average life of a battery on my line is 40 hours, and the standard deviation of batteries coming off my line are 1.2 hours. So let's say I have a customer that calls me and says, my battery only lasted 42 hours and I think I should get a refund. So I want to find the probability that a randomly selected battery would last longer than 42 hours. So I want to see, is she correct? Should I give her a refund based on the fact that her battery only lasted 42 hours? All right, so in order to do that, I'm going to head on over to Desmos. And I'm going to go to the functions menu. And up here, you got different tabs. I'm going to go to the distribution tab. And I'm going to pick normal distribution right there on the left-hand side, kind of halfway down. All right, so it shows me, it says normal dist, and then it's looking for the mean and the standard deviation. So my mean is 40, and my standard deviation is 1.2. All right, so then I close the parentheses. So it's mean, comma, standard deviation. And then what I want to do here is check this box right here that says cumulative distribution, or find cumulative probability. So this is the area under the normal curve. So if I head on over here to the curve, I can see 40. There's my mean. It's right there in the middle of the normal curve. And I want to find the probability of a battery lasting 42 hours or more. So the or more means that I want to highlight to the right of 42. So what I'm going to do is I'm going to put the min, the low value, as 42 and the max value as infinity. So as you can see here, I've shaded the graph from 42 on up. If I wanted the probability of a battery lasting less than 42 hours, then the min would be negative infinity and the max would be 42. So I would shade everything on the other side to the left of where I've shaded this. And as you can see right there on my screen, in the gray box right there, it says 0.047. So when I go back to my my problem here, I get 0.047. So I'm going to change that to a percentage, which means I'm going to move the decimal point 2 places to the right, and I end up with 4.7%. So the probability of randomly selecting a battery off of my line that lasts longer than 42 hours is 4.7%. or 0.047. Either one of these two answers is fine, but this is the one you'll see most often. So the woman that called me and complained that her battery only lasted 42 hours, she actually got a really good battery because only 4.7% of batteries actually last longer than that come off the line. So she actually got one of the better batteries in the whole batch.